So we've been talking about linear equations and linear functions and their slope and rate of change, but not everything is linear. So here we have a diagram of height in inches, and this is for males. I believe they're just males, and it's based on their age. Okay, so you can see, the average height is, for a little child at age 1, and then it kind of goes up pretty quickly till about age 5, and then it goes up, but not quite as quickly, to age 10, and then that's going to about, age 13, and then there's another big jump, and then it starts to kind of level off. So this is a function, this blue line here that they have, it's a function, passes the vertical line test, but it's not linear. What we've done, though, or what they did in the picture, is they have a point here that they've identified. And so they're saying there's a point, the average age of a 13-year-old boy is, or average height, is 57 inches. And then they also have a point here that the average age, or the age, at the age of 18, the average height is 76 inches, okay? So those are 2 points that they've identified on the function. Then they've drawn a line between those 2 points. That is called a secant line. Now, you'll hear the word secant in trigonometry, that's different, but this is called a secant line. And you can figure out the slope of that line based on these 2 points, and that would give you an average rate of change between the ages of 13 and 18, okay? Now, if I were to draw a different secant line, so let's say I was starting here as a 1-year-old, and I was saying, well, what about that 18-year-old? That would be a different secant line. It would have a different average rate of change, okay? And you could pick 2 other points, right? All right. So you have to go by the points that they give you when you're doing an average rate of change, and it's read off the function. Okay, so that's with a graph. Now they've given us some equations. Let me see if I can make this a little bit bigger. Okay. All right. Find the, well, maybe too big. All right. Find the average rate of change of, and they give me an equation here. That's my function. I can actually draw that function if I want to. It would take me a little bit of time, but it winds up being what we call a parabola. We're going to graph those in another chapter. But it's going to look something like that. Okay, so if we go from 0 to 1. Oh, I forgot to give you the formula for average rate of change. Where should I put that? I'll put it right here. So the average rate of change is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So it's very similar to the slope formula. In fact, that's what you're doing. You're finding the slope. But you're basing it on a function, not a point necessarily that they give you. Okay? Now, we could have done it because we knew for our height problem here, we knew 2 points. So we could have just calculated the slope of that secant line, same like we have done before when we've been given 2 points. But if they don't give you the points, but they give you an equation for the function, you're going to have to use that. Okay, so see if we can get this to work. So what I have to do is I have to find f of x sub 2, and then I'm going to subtract f of x sub 1, and then in the denominator I'm just going to have x sub 2 minus x sub 1. So it's very similar to the slope formula. Okay, well, how am I going to find f of 1? Now, why am I putting 1? Because that's what x sub 2 is. Minus f sub 0 over 1 minus 0. Okay, well, I'm going to go to the function. So here's my function, and I'm going to put in 1. So that's going to be 1 squared minus 0 squared over 1 minus 0. So I think I'm going to get 1 minus 0 over 1, which is just going to be 1. So the average rate of change is going to be 1 between those 2 points. So if I go back to my little diagram over here, here's 0, x being 0, here's x being 1. I could draw the secant line, and the slope of that, I don't have it drawn very well, but the slope of that would be 1. Okay, now we're going to go from 1 to 2. So we have to find f of 2 minus f of 1 over 2 minus 1. So what's f of 2? Well, you're going back to the function. You have to evaluate the function at 2. Minus f of 1, which we already did that, but we'll write it in. And then 2 minus 1 is 1. So what do I get? 4 minus 1 over 1, or 3. That would be the average rate of change then. So if I move up, let's see if I can do it in a different color, up to like this point, that secant line has a slope of 3. Okay, now we're going to do this last one. So it's going to be f of 0 minus f of negative 2 over 0 minus negative 2. Okay, so you're going to have 0 squared minus negative 2 squared over 2, or negative 4 over 2, which is negative 2. All right, that's then the average rate of change. Now look at the diagram. From negative 2, so like over here, to 0, so you're talking about a secant line right here. And then see how that secant line is negative, and the slope is 2, negative 2. Okay, there you go. Average rate of change.